Hello everyone, my name is Professor Dhanashree Wagh from Fulton Education Society, College of Engineering, Fulton from AIDS department. Today we will learn how to implement a simple hash table in Python. So we will see both chaining and open addressing method in that. So let's begin. So in this practical, we see these are the content. So first we have to see concept of hash table, then what is collision. Also we have to see the chaining method to handle collision. Then we will demonstrate the program implementation and show the output. So let's begin with the concept of hashing. So first we have to see the definition of hash table. In that, a hash table is a data structure that stores the data in array format, and each, each element is identified by a unique key. The key is a transform into an array index using a hash function. So this allow fast insertion, searching, and also deletion of that data. So this is the hash table. So what is collision? Um Sometimes two different keys produce the same index after applying the hash function. So this situation is called as a collision. And collision are common in the hash table and we need special method to handle them. So which are the collision handling technique? One popular method to handle collision is chaining, also called as a separate chaining. And this method, each index of the hash table contain a linked list. When multiple keys hash into the same index, they are stored in this list, and this way, no data is lost and we can still access all keys efficiently. So, another method to handle collision is called as a open addressing. Unlike chaining, in open addressing, all keys are stored directly in the hash table array itself. So, if a collision occurs, we find another empty slot in the table using a probing sequence. So, there are the several ways to find the next available slot, like linear probing, then quadratic probing, and third one is a double hashing. So, let's demonstration. So, first we have to perform separate chain. Size set the size of the function. Sorry, hash table. So HD chain is a list of one list for each index. So then we will perform. So each inner list will store the keys that collide at the same index. So then we can add keys. So these are the keys we want to insert into the hash table. Then we can take the control loop. So in that, for each key, compute its index using the hash function like a key modulus size. So append the key to the list at the index. If multiple keys hash to the same index, they are stored in the same list. Then collision handled by chaining. So that way, loop through all the indices and print the key stored in the each list. Then how to show the collision arc chain? So we take the for loop for I in range, then print all the element in the list. And then we take placeholder element. So this function I will call as a separate chaining. Then we can perform operation on open addressing. Same we can perform hd open, take a function, then can declare as a initially as a none. So that we define hd open. This function is a single list of sizes 5. So initially all slots are empty, that is a none. Then keys will be stored directly in this list. So for that we can take a control loop. Again take a control loop like a for key in key mod size of a list. So first we have to compute the initial index for the key using key modulus size. If the slot is occupied, move to the next index using the linear probing. So repeat until an empty slot is found, then we insert the key. So how to wrap around the table using modulus if we reach the end. So that's why we use. So that way we can wrap around the table using modular sign if we reach the end. Then how to print all these function. So we can perform print function, print hash table in open addressing mode. Then again we take a control loop, like we can check for I in range, that we define the size of that at the hash table, then colon. Then again we can perform all this using placeholder, like then index element. So index. So that we print all the indices of the table and show where each key in a store after resolving collision. So overall, what we do, chaining means keep all the collide keys in one list. And second method is open addressing, find next empty place in the table. So let's run the program. So in that chaining, keep all the collide keys in one list and open addressing, find the next empty place in the table. So check our output. In separate chaining, all keys like 7, 12, 17, and 22 give the same index in that. Give the same index like 2, because key modulus 5 is equal to 2. So all the keys are placed in second index. So they are all go in a one list at index 2 and other indices are empty, like a 0, 1, 3 and 4. These indices are empty. Then show the open addressing. In that, first key 7 goes at index 2. Then 12 also get the index 2, but it's full. Move to the 3. 3 is the next empty slot. Again 17 move to 4 and 22 move to the next empty. index at 0. So wrap around. So keys are stored at 2, 3, 4, and 0 indexes. Let's see. So we learn what hashing is and how collision are handled using separate chaining and open-end tracing. So both method are store the data efficiently and make searching faster. I hope this explanation is easy. Both methods are store efficiently and make searching faster. So thank you for watching.